Hello students, welcome back to the lecture series on discrete mathematics. We are learning logic and this is video part 10. In the previous session we have learned the propositional logic and propositional equivalences, predicates and quantifiers, and in this video we are going to learn argument in propositional logic, rules of inference and arguments. Let us see the definition. An argument is conclusion justified by premise. You can also call the premises hypothesis, where conclusion is proposition which is claimed to be justified and hypothesis is set of propositions which are used to justify the conclusion. That is, if P with propositions P1, P2 up to Pn is premise and C is conclusion justified by premise, then P1, P2 up to Pn yields C is called an argument. The symbol here is read as yields. The argument is said to be valid if P1 and P2 up to Pn, if altogether all the propositions are considered to be true, or if they are taken to be in the AND statement, it should imply the C is a tautology. Otherwise, the argument is said to be invalid or a fallacy. Thus, an argument is invalid if premise P1 and P2 and P3 up to and Pn is true, but conclusion C is false. We have some rules of inference. Let us see the first rule. The name of the rule is detachment or rule of modus ponens. It says P, P implies Q yields Q. That means if proposition P is there and if we have P implying Q, if P then Q, then we have Q as the conclusion. The second rule is contrapositive or rule of modus tollens. It states negation Q, P implies Q yields negation P. This is the argument which say that negation Q and P implying Q will give rise to negation P. Here P implying Q is equivalent to saying negation Q implies negation P. Since we have seen that P implying Q, this implication sentence is equivalent to the contrapositive negation Q implies negation P, and therefore we have negation P as the conclusion. The third one, disjunctive addition or rule of addition. P yields P or Q yields P or Q. So if P is true, then either P or Q is always true, or if Q is true, then P or Q is always true. The fourth one is P or Q, negation P. This is going to yield the conclusion as Q. Since we have the negation P and out of P or Q, we are going to the conclusion Q, and it is same as saying P or Q, negation Q will yield P. This is called disjunctive simplification or rule of disjunctive syllogism. Then we have conjunctive simplification or rule of simplification. P and Q will yield P, or P and Q will yield Q. Then we have the chain rule as P implying Q and Q implying R, which will yield P implying R. That means if P then Q and if Q then R, then we have if P then R. This is called chain rule or rule of hypothetical syllogism. We have few more rules: rule of exportation, rule of importation, conditional equivalences, material implication, biconditional equivalences, material equivalences, or resolution. Let us go to the example where this will be more clear. What rule of inference is used in each of these arguments? The first argument is Jerry is a mathematics major and a computer science major. Therefore, Jerry is a mathematics major. Consider the first preposition as P, which is Jerry is a mathematics major, and the second preposition as Q, which is Jerry is a computer science major. Then symbolically we can write the given argument as P and Q yields Q. This is rule of simplification. In the second example, if it snows today, the university will close. The university is not closed today, therefore it did not snow today. The statement after the therefore it did not snow today is the conclusion. Let us see the prepositions involved here. Let P, it snows today, and Q be the university will close. So if it snows today and university will close is sentence if P then Q, that is P implying Q. The next statement is the university is not closed today. So it is negation of the statement Q. So we have negation Q. So by rule of modus tollens, we have negation Q and P implying Q, that this will give me conclusion as negation P, which is it did not snow today. So this way we write it in the symbolic form, and the rules of inference are written here accordingly. We will continue in the next lecture. Thank you.